The problem is to count the number of good strings of length between low and high, where a good string is defined as a string that contains at most 0 number of zeros and at most 1 number of ones. To solve this problem, we can use dynamic programming to build a solution iteratively from smaller subproblems. We can use an array dp of I to store the number of good strings of length I. We can start with dp of 0 is equal to 1, because there is only one empty string of length 0, which is a good string. Then, for each length I from 1 to high, we can compute dp of I by adding the number of good strings we can obtain by appending 0 or 1 to a shorter good string. We can then add up the number of good strings of each valid length between low and high to get the final answer. Code. Let's take an example to understand how this code works. Suppose low equals 2, high equals 4, 0 equals 1, and 1 equals 1. We want to count the number of good strings of length between 2 and 4 that contain at most 1 0 and at most 1 1. We can initialize the dp array as follows. Notice that dp of I represents the number of good strings of length I, and we can obtain dp of I by adding the number of good strings we can obtain by appending 0 or 1 to a shorter good string. For example, dp of 2 equals dp of 1, appending 0, plus dp of 0, appending 1. We can then add up the number of good strings of each valid length between 2 and 4 to get the final answer. So there are 10 good strings of length between 2 and 4 that contain at most one consecutive occurrence of 0 and 1. The time complexity of this approach is big O(n) because we need to iterate over each length from 1 to n to compute the number of good strings for that length. For each length, we only need to perform 2 constant time operations to update the dp array, so the time complexity of each iteration is big O(1). Therefore, the overall time complexity is big O(n). The space complexity is also big O(n) because we need to store the number of good strings for each length up to n in the dp array. Since the number of good strings for each length depends only on the number of good strings for shorter lengths, we can update the dp array in place without needing to store any additional information. Therefore, the space complexity is also big O(n).